Welcome back. At first, Happy Diwali and Happy Dhanteras. May this Diwali give you endless joy and golden moments. Since this is the festival season, so today I will discuss some question of linear algebra which had come in comparative exam just as a review, since this is the festival season. See the first example. First example, let M5C be the complex vector space of 5 cross 5 matrices with entries in complex number, and let V be a non-zero subspace of M5C. That means this is the 5 cross 5 matrix in complex field, such that every non-zero A belongs to V is invertible. Then which of the following are possible value for the dimension of the vector space? Option 1, 1. Option 2, 2. Option 3, 3. And option 4 is 4. Which had come in 25th June 2024 exam. This type of example actually very basic question. Here have considered 5 cross 5 matrices with complex entries, and V be a subspace of 5 cross 5 matrices such that every non-zero A is invertible. That means V contains those A which be invertible. That means date of those A such that date of A not equal to 0. Then which of the following are possible value for the dimension of the vector? For example, if we consider this type of invertible matrix, then their sum would be 0, 0, 0, 0, 0, 0, 0, 2, 0, 0, 0, 0, 0, so on. And notice here date of C is C equal to 0. So if you consider this type of invertible matrix, then their sum does not belongs to this subspace. That means in here only we have to consider those type of matrices, those type of invertible matrices which satisfy the properties of subspace, because if you consider these type of invertible matrices, this is not satisfy the properties of subspaces. So in which only contains those type of invertible matrices which satisfy the properties of subspace. Next I will say, my all viewers have understood the concept. Now we have to find the possible values of dimension of the vector space V. Okay. First consider the dimension of the vector space V equal to 2. If possible dimension of the vector space equal to 2, then that means V equal to span of A comma B, where A and B are both linearly independent. That means date of A not equal to 0 and date of B not equal to 0. Okay? Since A and B both belongs to the V, and since V is a subspace, so date of A plus lambda B also not equal to 0, and this is true for all lambda belongs to real number. And obviously A plus lambda B is a polynomial of degree 5. Since this is the odd degree polynomial, so it has a, obviously it has a root. We all of us know by fundamental theorem of algebra. Since it has a root, That means there exists at least one lambda belongs to R for which A plus lambda b, det of A plus lambda b would be equal to 0. This is by fundamental theorem of algebra we can tell it, and it contradicts this condition. So this subspace cannot contain two elements, so it cannot be 2. Since it cannot be 2, that means similarly it cannot be 3, 4. That means only possibility is 1. I hope my all viewers have understood this question. Okay? OL. Example which also had come in CSIR NET June 2024 exam. The question is AB 4 class 4 real matrix whose minimal polynomial is x square plus x plus 1 and let b equal to a plus I4. Then which of the following statement are necessarily true? Option 1, the minimal polynomial of b is x square plus x plus 1. Option 2, the minimal polynomial of b is x square minus x plus 1. Option 3, b cube equal to I4. And option 4, b cube plus I4 equal to 0. Which of the following is true? This is very conceptual question. We all of us know eigenvalue of minimal polynomial is the eigenvalue of the matrix. Here given A is 4 cross 4 matrix and the minimal polynomial of A is x square plus x plus 1. This is means actually x plus omega, x plus x minus omega square. That means the root are, x minus omega square. Root of A are omega square. This is the eigenvalue of A. Eigenvalue of the matrix A. And also we all of us know if the root of minimal polynomial are distinct, then the matrix is diagonalizable. Since here the root of the minimal polynomial omega and omega square, so matrix A is diagonalizable. That means I have got the matrix A is diagonalizable. But we have to find all question about B, where B equal to A plus I4, where A is diagonalizable. And we all of us know identity matrix also diagonalizable. Up to diagonalizable matrix may or may not be diagonalizable. But since this is only the scalar, so obviously sum of two, one scalar sum and another matrix, so these sum obviously be diagonalizable. Okay, therefore B is also diagonalizable. That means eigenvalue of B would be 1 plus omega and 1 plus omega square. And we all of us know 1 plus omega square equal to 0. That imply 1 plus omega equal to minus omega square. That means this value is equal to minus omega square and 1 plus omega square means minus omega. So the minimal polynomial are x plus omega square and x minus omega. This is also minus omega. So this is x plus omega. That imply x square plus omega square x plus omega cube. That imply x square plus omega times x plus omega cube. And this imply x square plus, since omega plus omega square equal to 0, that means omega plus omega square means minus 1x plus 1. That means that imply x square minus x plus 1, and this is the minimal polynomial of the matrix B. So the minimal polynomial of B is x square minus x plus 1. I hope my all viewers have understood. So we all of us know any matrix satisfy the minimal polynomial. So that imply B square minus B plus identity equal to 0. And that imply B square minus B equal to minus I4. So notice the option B square plus I4 equal to B. Okay. Now we have to find the B cube. So for this, just multiply again B. B cube plus B equal to B square. Now put the value of B square. B square equal to B minus I4. So put the value. This value would be B minus I4. So B cube equal to actually minus I4. I hope my all viewers have understood. That imply B cube plus I4 equal to 0. So option 4 also right option. That means 2 and 4 be the right option. I hope my all viewers have understood this type of question. Example, okay. Which had come CSIR NET 2023's June exam. The question is TB 3x3 real matrix with characteristic polynomial A is equal to PT, and PT is divisible by T square. Here notice PT is just a polynomial, and which is divisible by T square. That means PT would be such type T square times this type of factor. But here given TB 3x3 matrix, so this would be T minus alpha times. Then which of the following is true? 1. All the eigenvalue of A are real. Option 2, A cube equal to 0. Option 3, A is diagonalizable. And option 4, eigenspace of the eigenvalue 0 is 2-dimensional. Here, characteristic polynomial of A. Here the question about A. And characteristic polynomial of A is equal to PT. So, the characteristic polynomial of the matrix would be such type A square times A minus alpha. That means the matrix A would be such type 0, 0, 0, 0, 0, 0, 0, alpha. Because here the eigenvalue 0 with multiplicity 2 and other eigenvalue is alpha. Since here the eigenvalue is 0 and alpha, so matrix also can be 0 A B, 0 0 C, 0 0 alpha. Notice here also eigenvalue is 0 and alpha. That means either this type or this type matrix would be. Here first option, all the eigenvalue are real. Notice for both case all the eigenvalue is 0 0 alpha. Since TV 3x3 real matrix, so all the eigenvalue are real. This is right option. A cube equal to 0. Notice for this case the eigenvalue of A square would be 0 0 alpha square, and eigenvalue of A cube equal to 0 0 alpha cube. And here the question is A cube equal to 0. We all of us know if A cube equal to 0, then eigenvalue are both 0 0 0 0. But here I have got a cube equal to 0 0 alpha cube. So a cube equal to 0, this is not possible. Option 3 is a is diagonalizable, and option 4 eigenspace of the eigenvalue 0 is two dimensional. For this, here we have to at first see the fourth option. Here we have to find the geometric multiplicity, because eigenspace of 0 means geometric multiplicity. Here notice, we all of us know eigenspace of 0 would be n minus rank of a minus lambda I. Rank of a minus, here lambda is 0 0 I, and this would be, notice, if you consider only this matrix, here geometric multiplicity rank of a minus lambda I is 1, geometric multiplicity is 3 minus 1 is 2. Here the algebraic multiplicity and geometric multiplicity are same, but for this case rank of a minus 0 I, this value would be, for this case rank of a minus 0 I, this value would be 2. So n minus rank of a minus 0 I, this value is 3 minus 2 means 1. So here the geometric multiplicity is 1 for this case, and for this type of matrix, this is break. Option 4 is break. Eigenspace of 0 is two dimensional, this is the wrong option. And option 3 is diagonalizable. Since here I have got here two distinct, here same eigenvalue, but geometric multiplicity is not equal to, in this case geometric multiplicity is not equal to arithmetic multiplicity, so A is not diagonalizable. Means only option 1 is a right option. I hope my all viewers have understood this question clearly. Okay? Oh well. But this type of question actually very important, because if some student only take this matrix, because here eigenvalue is 0 0 alpha and this is the easy matrix, then all option would be wrong. And this type of option, eigenspace of 0 is two dimensional, this is wrong option. This is violate only this type of matrix. So if you don't take this type of matrix, so all option would be false. So in this question, actually when the eigenvalue would be such type 0 0 alpha, what can be the structure of matrix? This is actually main goal of this question. If you construct this type of matrix, then you can easily solve this type of question, because you all of us know what is the eigenspace when a matrix be diagonalizable. But if you not construct this matrix also, then all option would be wrong. I hope my all viewers have understood what I want to say. Okay? So try to understand, try to construct any matrix by eigenvalue easily. Okay? Well, I will stop here. Happy Dhanteras again. You know, actually Dhanteras is celebrated as it is birthday of Dhanvantari, who is the father of medicine and Ayurveda. Actually, the real dhan is our health. So today, let's all pray for each other and our families for the best health for everyone, physically, spiritually, emotionally and mentally. So let's pray for everyone. for good health, not only physically, spiritually and mentally. Happy Dhanteras again. And see all the question with pay attention. Okay? Well.